In the last section, we made the hero runs and jumps on the platform. In this section, let's work on the collision detection logic. We will implement the enemy game object, and then we'll check the collision between the enemy and hero. Then we make the collision detect logic generic to fit different types of game objects. Next, we create another new type of game object, the coins, and also handle the collision between the hero and the coins. Let's work with the first video of the section, implementing the enemy game object. In this video, we define a new type of game object, the enemy. We will define the class which uses the obstacle graphic. Then, we define how the enemy moves on the platform. Next, we place an instance of enemy on the platform. At last, we add the missing background graphic to the game. The enemy is a moving game object. We are going to move them on the platform. We create a new class named enemy that extends movable game object. In the constructor, we call super with an instance of lib.obstacleGraphic as the parameter. If we take a look at the definition of the movable game object, it takes a graphic parameter, which is required by the game object, which in turn will display the graphic by adding it as a child of the display list. We want to move the enemy left and right on the platform. We need 4 variables for that. The direction x has either value +1 or -1. It tells if the enemy should move to the right or left. Speed is how far it moves on each step. We can make it move slow by using 0.5. Offset is how far it is away from the original position x. The default is 0. This means that offset has made no movement yet. The max offset is the maximum offset the enemy make before it turns around into the other direction. We register the tick to implement the move logic. Inside the tick event handler, we move the enemy by setting the velocity. All movable game object with a velocity will be moved automatically. We store the accumulated offset value. If the accumulated offset is larger than the maximum offset, we change the direction by multiplying -1. Now, we place an instance of the enemy on the platform to see how our code works. We can do that in the world class. We create a new enemy and set the XY position to be on the platform. Then, we add the enemy as a child of the world, which is added to the stage. Before moving on, we would like to include the background into the game as well. Our background graphic won't move with the world, so we place the background directly on the stage as a sibling of the world instance. The restart game method in the game class, we add the background graphic before adding the world instance. In this video, we defined an enemy game object and made it move. We also included the background graphic to the stage. In the next video, we will implement the detection between hero and enemy.